Hello and welcome back to another video. So we're going to be having a quick look at taking the derivative of the inverse tan function, also known as the arctan function. Okay, so let's dive right in. The first thing that we're going to do is we're going to say let y equal to tan inverse of x. Okay, and so now what I'm going to do next is simply take the tangent of both sides of this equation. So that will become now tan of y is going to be equal to tan of inverse tan of x, and we know that that will cancel out now on the right hand side, so all we're left with there is x. Okay, so next step, now we want to differentiate both sides of this equation, so that will now become d dx of tan of y and d dx of x. Okay, so let's work out with the d dx tan of y first of all. So I'll write that down below, and I'm going to simplify this and just to really illustrate very clearly what's exactly going on here. So this will just end up being an application of the chain rule, but I just want to show you. So I'm going to say let u equal to tan of y, just so that way it looks a little bit nicer. So then I'll say du dx. Well, I can say now that du dx is going to be equal to du dy times by dy dx. Okay, so du dy, well, let's just differentiate this equation here with respect to y, and let's see what we get. So that's now going to become simply sec squared of y, and then times by dy dx. Okay, so we don't need to go through all of this extra work here, but this is just to help illustrate exactly what's going on. So now we have sec squared y dy dx, and that's going to be equal to, as we said above, dx dx, so 1, in other words. Okay, so now we have something we can actually work with. So now we have dy dx, which is exactly what we're looking for. So let's rearrange this, and we'll end up with dy dx is equal to 1 over sec squared y. And now we're going to make use of our favorite trigonometric identity here. So sine squared of y plus cos squared of y equals 1. Okay, so what happens if I divide everything by cos squared y? Let's see what happens. So cos squared y and then cos squared y on the end there, of course. So cos squared y on cos squared y, that will cancel out, and that will just simply become a 1. Sine squared y over cos squared y, well, that is going to simply become a tan squared y. And then 1 over cos squared y, that is sec squared y. So what we're going to do now is use this identity here and simply rewrite this out now as 1 over tan squared y plus 1. Okay, and now let's quickly remind ourselves, way back at the start, we had said that tan of y was equal to x. Okay, so we're going to use that now and rewrite this out now as 1 over x squared plus 1. And that is dy dx, where we had that y was equal to tan inverse of x. So therefore we have shown that d dx of the tan inverse function of x is in fact equal to 1 over x squared plus 1 as required. And there we are. So there are actually a few other ways to go about solving this problem. This is probably just one of the most generic methods, and it's going to be useful as well to go through and solve for the other arc functions and inverse functions and all that sort of stuff. So if you do have any other methods for how you would solve this problem, then by all means, please leave them down in the comment section below. And if you have enjoyed today's video, then please leave a like. And if you want to see more content like this, please consider subscribing and let me know what you'd like to see more of in the future. Thank you very much for watching, and as always, stay curious.